a new topic, section 2.6, Introduction to Functions. And I will read here this definition of a function, and probably you will not understand just by reading the definition. Don't be worried, because I think you're going to understand, and I'm saying it's a lot, but let's keep it simple. We will understand on the examples, by working on the examples. It's very straightforward, very simple. Function is a special kind of relation, and I'm going to show you on the examples, and I think you're going to understand. But let us read the definition, and maybe you're not going to understand, and you will actually see clearly on the examples. Given a relation in x and y, we say y is a function of x if for each element of x in the domain there is exactly one value of y in the range. So the key words are this: exactly one value of y. It's just one and only one value of y for each x. So relation is anything that links a value of x with a value of y. And function is a special kind of relation that only one y for each x. Only one value of y for each x. And moving to the examples so we can actually visualize. Let's start from letter C, then letter B, and letter A. Okay? Let's check, determine which of the relations define y as a function of x. Let's find out, let's figure out which ones are a function or not a function. Letter C, can you check each value of x have only one line leaving and ending in just one y, one value of y. So for each x, just one line, just one link, just one connection, just one relation. So this is a function. Yes, it is a function. Next example, letter B. So letter B, let's check if it is a function or not. For each value of y, there is only one arrow, one link, only one connection, one relation with a value for each value of x, only one value of y. So yes, this is a function. Now let's check letter A. Here is fine, only one arrow leaving x and going to y. The same thing here, only one arrow leaving x and going to y. But there's a problem, check it out this. We have two arrows leaving x and going to y, two arrows, and ending up in two different values of y. So that means if we have two or more arrows, this is not a function. Not function. Is this clear? If it's not clear yet, I think the next example I'm going to show you will make it a little bit easier. I'm going to ask you about the next thing. Let me clear this up. And this is the explanation, the solution of this example, if you want to check this out later. And what is this? What is this? Check the screen. What is this? I'm going to say this is a relation because for each product, there's a price. So there's a relation. The domain are the products in the supermarket, and the range is the price. Okay, the domain are the products and the range are the prices. Is this a relation? I'm going to say yes. Yes, it is a relation because we have this domain and range, products and prices. Is this a function? I'm asking you. Let me know here. Type in the chat box what do you think. What do you think? Is this a function? or it is not a function? It is a function or it is not a function? And remember, for the function, you need to have only one y, one element on the range for each x. Only one y for each x. What do you think? Type here. So Kalia, Ryan, is not a function. Kalia says not a function. Ryan, Maddie, Joniel, Noelia, what do you think? Anjali, Alexis, Keon, Jacob, what do you think? Is this a function? Is not a function? Kalia said it's not a function. Serenity, good morning, Serenity. Good morning. Do you think, I know you just joined it, but do you think there's a function or not a function? Maddie says not a function. Not a function. Chris DL says not a function. Let's think, let me ask you something. When you go to the cashier, you're going to pay for the product. Is the cashier is going to ever ask you, what's the price you want to pay for this product? Is for this ice cream, is $2.99 or $5? Do you ever going to have a product with two prices or three prices? And Jacob said it's not a function. Do you ever going to have a product with two prices, three prices, more than one price? I don't think so, right? If you go to the cashier, he's going to check the price, and that's going to be on your check, on your bill. For each product, there is only one price. For each product, only one value that you have to pay, right? I never found something in the supermarket, something that have two prices, and you can choose. Oh, you can choose this price, the $3 or $5. No, that's never going to happen. Sometimes you can have coupons, you have discounts, but you don't have a product with two price tags, right? That means it is a function. Yes, it is a function, because there's only one price, there's only one value of y for each x. Only one value of y for each x. And y is going to be the price, and x the products. You can have different products. Let's say this pineapple and the other one, the cheese. They have the same price. Not a problem. Not a problem. They can have the same price. And like this one here, the milk and the whipped cream, they can have the same price. Not a problem. They can have the same price. What a function cannot have is one product with two prices. One x with two y's. Okay? Makes sense this? So you said not a function, but actually it is a function. It is a function. Yes, it is a function, because for each product there's only one and only one price. Okay? Is that clear? If it's still not clear, maybe we're gonna understand later on the quiz. But it's better. Yeah, good, Jacob. Thank you for the feedback. If it started to make sense, it's kind of a special relation, and you can remember this thing of the supermarket is a good thing to remember. Oh, X is going to be the product, Y is going to be the price. Only one price for each product. Only one Y for each X. Yeah, thank you, Kalia. Let's move to the next. And I like to say, keep things simple. Keep things about the vertical line test. Keep things simple. Let me read the procedure, and I'm going to show the example that this actually is something very, very simple. Procedure, the vertical line test. Consider a relation defined by a set of points, x and y, in a rectangular coordinate system. The graph defines y as a function of x if no vertical line intersects the graph in more than one point. So this is the procedure, the definition. It might be difficult to understand if you just read this, but I think it's going to be pretty easy to understand when we work this out here on the examples. And we have a few examples. two examples, actually, two graphs, two examples. And this first one, let's draw lines, vertical lines. We need vertical lines, okay? So draw a vertical line here and here, a vertical line here and here and here and here. Okay, and here the same thing. I'm assuming this graph. See the arrows. This graph kind of looks like this, goes like this. So I'm gonna draw vertical lines. If you find one, and you just need one line intersecting or crossing the graph in 2 points, then you can say this graph is not a function. Because for one x have two y's, so not a function. Not a function. But if you cannot figure out at all one line that intersects the graph in more than 1 point, check it out, just 1 point, just one, just one, just one, then yes, it is a function. Okay? So keep it simple. It's as simple as that. You found just one line that can cross the graph in 2 points. It's not a function. You cannot find a line that crosses the graph in 2 points. Yes, it is a function. Let me show here one example that might be tricky. Let's say this is x and y, and you have a graph like that. Let's see. See? And then you try make a vertical line here, and make a vertical line here, make a vertical line here, and you find just 1 point, just 1 point, just 1 point. But actually you have to try to find one line that crosses the graph in more than 1 point. And this one line crosses in 1, 2, maybe even 3. If there's only one line that you can find out, that you figure out, that cross the graph in 2 points, that's it. Not a function anymore. Not a function. There's one line. Okay? And I think this concludes the presentation. There's the explanation. Actually, you can see it next. A quick explanation. And we will work on the quiz on this subject, on this topic. And I'm pretty sure you're going to understand when we work together on the quiz. You're going to figure out how to apply the vertical line test and how to identify if a graph is a function or is not a function. Any questions so far? So far, are we good? We will have a quick break. It's not a break, but it's a break, a brain break to work on our bell work. Because the bell work is kind of something that we have to relax, right? We have a pretty simple bell work today, but don't follow for the trap. If 11 workers can build 11 cars in 11 days, how many days would take 7 workers to build 7 cars? But don't answer 7 days. Don't answer 7 days. This is the trap. This is the thing to make you make a mistake, right? Try to figure out. We're going to assume this is a linear relation, and try to figure out, and type now. Type your guesses. Type your guesses now. So you define that each one worker, we're going to build 1 car in 11 days. The answer is going to be 11. 11 is the right answer for the bell work. The first part of the quiz, use the vertical line test to determine whether the relation defines y as a function of x. This is the first part. And the second part is kind of the same that we've been working, we worked it before, is to find the range and the domain given the graph. But only the difference here is because we're going to check some traps that we have. The open dot, the closed dot, and the arrows, okay? So we will be careful with these traps. We're going to know how to work with these traps. Let's work the first one. Let me get the first example. Pretty simple, pretty simple. There are actually two questions that you have to answer. You have to select two choices. One of the choices is asking if it's a relation or it's not a relation. Actually, all the options here, A, B, C, D, E, and F, all relations. You can type the option, actually the right option is that all are relations, okay? But now let's check if it is a function or if it's not a function. Is the next question. If it is a function or not a function. So you draw the vertical line. Draw the vertical line. If the vertical line crosses in 2 points, or more, then it's not a function. And that's as simple as that. That's it that you have to do. You have to find one, you just need one vertical line. One vertical line that crosses the graph in 2 points, and that's it, is not a function. Okay? Now try by yourselves. Try a B, C, D, E, and F. And after that, you can work together on the next problems from G to the last one, I think is N. Yes, N.